This is it, people. Adding and subtracting proper fractions. This is the thing that people can't do. And when I say people can't do, I mean most people can't do. So you're going to learn 3 examples. It covers all the bases of adding and subtracting proper fractions. Here we go. I'll try to make this simple and clear for you. At any point, hit pause on the video. If you think you can do those 2 right now, do it and see if you're right and check it with my work. All right, here we go. We need a fancy color here like that right there. Okay, when you're adding and subtracting fractions, you have to have the same size denominators. You have to have the same size pieces. And the denominators of fractions tell you what size piece you have. So we got eighths and tenths. You can't add those together until you cut them into the same size pieces. So in the previous video that talked about building up fractions, that's exactly what we were doing. We were cutting the pizza up into equal size slices and then adding them together. Let me show you. We have to get common denominators and build this up, which means we have to start with the LCD. So 8 and 10. 8 does not go into 10, so you have to do 10 times 2, 10 times 3, 10 times 4, until 8 goes into it, and you can see that's going to be 40. So you come down here and you set yourself up like this. I cannot tell you how important this is to set yourself up so that all you have to do is fill in these 2 blanks and then do the problem. And remember, before we did it like this. 8 times what is 40? Well, that was 8 times 5, and that is 40. So you multiply the top by 5 as well, and that's 15. Now, I don't recommend writing this every time, but for demonstration purposes, I'm going to. 10 times what is 40? That's 10 times 4. So 3 times 4 is 12. And when you add these fractions together, the size of the piece stays the same. 40, 40, and 40. The tops get added together, so that's going to be 27 over 40. And then you should try to reduce this, and it will not reduce. Okay, we're back. I don't know what happened there, but here we go with the next one. Next one, we have to get common denominators again. 8 and 12, that's going to be 24, because 8 doesn't go into 12. 12 times 2 is 24, and 8 goes into 24. So that's what we're going to put down here. And this time we're subtracting. Make sure you don't get in a habit and do 3 adding problems in a row, and then they throw a subtraction problem in there. So make sure you're paying attention each time. 8 times what is 24? That's 8 times 3, so that's 24. So 7, multiply the top and bottom by each one, that's 21. 12 goes into 24 twice, and 2 times 1 is 2. That's how you would talk yourself through that. If you find comfort in writing that, go for it. So the bottom again stays the same when you're adding or subtracting. And on this, you would just do 21 minus 2, which is 19. You should always try to see if you can reduce these fractions. Never assume it's reduced all the way, because usually you have to, and on neither of these we had to reduce. But that's going to be coming up soon. Here's the next example. We have 3 of them this time. And I picked one that was simple so this video wouldn't drag out forever. But again, you would do the same thing. You try the biggest number, and 6 goes into it, and 8 goes into it. So that is going to be our least common denominator. And so we just do this process 3 times. 8 times what is 24? I'm going to try this without writing it each time. 8 times what is 24? That's 3. And 3 times 7 is 21. 6 times what's 24? That's 4. 4 times 5 is 20. And this one, well, you could say 24 times what is 24, and that's 1, and 1 times 7 is 7. But these 2 fractions are the same, so make sure you keep them that. The bottom is 24. The top, 21 plus 20 plus 7 is 48. And so 48 over 24 actually becomes a whole number of 2 over 1, which we just call 2. Thanks for watching. Go back, try it again, recopy the problems, and see if you can do it. Have a good one.